All right, guys. I wanted to get at least this module out to you guys. We're going to be going through module. Uh, sorry, I'm reading upside down here. Module 41. I know, I'm sorry, 40. So it's just going to be talking about ways that we deal with water pollution. We're not going to get into the specifics just yet. That'll be in 42. I think this is another four module chapter. I'm going to try to finish this chapter either tomorrow or the next day. So I'll post another video of me kind of going through the rest of this entire chapter. Which means, by the way, guys, we are on the last unit. It's a lengthy unit. I think it has 4 chapters to it. So, but I think we're going to be able to, like I said, get everything done that we need to have you guys all caught up on all the material that you'll need for the test. But this is chapter 14. I will have, of course, a reading test for you guys, reading quiz, I should say, for you guys probably at the end of the week. Okay, we'll do it maybe again on Friday. We'll see how that works out. But I think I like that. Let's go ahead and pray real quick, and then we'll get started on this. Lord God, I ask that in lieu of us not being here, let this be a fitting substitute. Let us learn, Lord, as much as we can from this. Lord, I pray that that my explanation, kind of going through this material with my students, is beneficial to them. And Lord, that you prepare us all for the test that we have at hand. Lord, last thing, just be with those that are ill. Help us, Lord, to come through this weird time in our lives better for it. In Jesus' name I pray. Amen. Okay. So we're going to talk about wastewater primarily today. Wastewater is it's basically the stuff that goes down the drain. This is obviously a much bigger sort of concern for things like industry and livestock. So if you are growing plants or animals for consumption, or if you are in the industrial field, there's a lot more wastewater probably. A lot of industry actually reuses their water, like we saw at the ConocoPhillips plant. However, when I think of wastewater, like personally, the thing that comes to mind is that faucet over there on the right. It's what goes down the drain. It's our water that has been used. However, it's not been usually used very effectively. If you're like me, I was brushing my teeth today, and I'll be honest, I did leave the water running way longer than I should have. I'm just not, I don't think about water consumption as much as I should. I don't think anyone does. And this is evident when we think about things like wastewater and how much it's aptly named, because water is truly wasted in this process. So there are concerns with wastewater. We have to do something with it. Wastewater just can't be pumped back into the Mississippi or wherever, just pumped outside your house, because eventually it'll make its way to the Mississippi and down to the Gulf of Mexico and into the ocean. That might not sound like a bad thing, and in a lot of ways it's not. When water, when it rains, that water does the exact same process. It finds its way to the lowest point, which is down to the Gulf of Mexico eventually. It's what it picks up, though, in the process that is kind of a concern. Okay, there are 2 types of pollution that we're looking for: either point source mutation, which is a distinct location from which a pollution is directly produced, for example, a factory or a home. But usually we don't pinpoint a specific home unless there's some sort of like tragic environmental disaster that's happening at that place. Most of the time, most of the pollution that I'm referring to when it comes to wastewater, like the water that comes from your house, is considered non-point. This is a broad area. So this would be like all the wastewater from all the residencies in Alton, Illinois. Okay, that would be a non-point source of water pollution or wastewater. Now, what happens with wastewater, why it's a concern, is because you can get what's called biochemical oxygen demand, a very low BOD, biochemical oxygen demand. This only occurs when the amount of oxygen, not oxygen, not sure why I have a P there, in the quantity of water it uses over time at a specific temperature. So if you have, let me reread that. That was the definition. I'm sorry. This is the amount of oxygen a quantity of water uses over a period of time at a specific temperature. If you have a low BOD, that means you have less pollution. Okay, that means you have less oxygen being used. If you have a high POD, that means you have more pollution. Now, why is that? That's because usually there's more bacteria and pathogens inside of that water. So living in that water, because that water is usually, because of pollution, it's nutrient dense. I know you're sitting there thinking, well, if there's pollution, wouldn't that kill off the organisms? It would. It would kill off things like fish and daphnia, and which are water fleas, and flatworms and things like that. Things that are actually beneficial, plants, things that are beneficial for the water, things that we find in things like lakes and ponds. But if you have a really high BOD, this oxygen demand, that means that you have less oxygen to go around. So you have very oxygen poor water, which is not going to support that kind of life. But it's still nutrient rich, because most of those pollutants are going to give you things like phosphate and nitrogen. So because it's nutrient rich but with low oxygen, you get very unfavorable sort of organisms living in it. Things like bacteria. Okay, and that water, if you drink that water, obviously if it's infested with bacteria, it's not going to. First off, it's not going to taste good, but it's also going to make you sick, which is obviously much more of an issue. Wastewater decomposes nutrients, or as wastewater decomposes, nutrients are released in a process called eutrophication. Like I said, you're pouring nutrients into this oxygen-poor environment. This causes organisms that are able to survive in those areas to survive and survive well. Usually you get algal blooms because of this. And again, you get this breeding ground for bacteria within this wastewater. So we have to do something with it. We have to somehow make it safe. That's our big challenge, because you don't want people swimming in that water. You don't want people trying to consume that water. And now, you sit there and you think to yourself, well, I've never went to a lake that's covered over in algae and thought to myself, well, I'm going to get a drink. That's not a concern for us nearly as much as it is a concern for other people around the world. There are places where that algae-covered water is the only source of water that a village might have. So it's very important to keep that water as clean as possible. Now, how do we do it? Well, there's sort of a simple way to do it, and there's a more complicated way to do it. We're going to talk about the simple way to do it first. But the first thing is you need to test the water to see what type of wastewater you have. If you have bacteria that are growing in it that are harmful to humans, if it's water that is fairly clean. So how do we test it? Well, we look for specific bacteria, and these are called indicator species. Now, indicator species can be almost anything. You can look at an indicator species, for example, you can look at crawfish in a stream or a pond. An abundance of crawfish will indicate that there's large amounts of small crustaceans that are feeding the crawfish. And if there's a lot of those, usually there's a lot of fish. It's just a good indication that lots of organisms are found within those waters. They're very productive and they're very healthy. But when we talk about water safety, we're looking for microorganisms more than anything else. Specifically, we're looking for fecal coliform bacteria. Coliform, excuse me. And the reason we're looking for fecal coliform bacteria is because these are the bacteria that are found within our own guts, okay, living off of our own waste, which sounds weird to look at, but what that indicates, if you find that type of bacteria in water, it indicates that there's got to be human waste also in that water, human excrement. It's got to be sewage, raw sewage. That would indicate, obviously, that is a bad source of water that needs to be treated. Okay, it's not one to consume, because if you consume that water, you're likely to ingest some of these fecal coliform bacteria. One of those is E. coli. Believe it or not, E. coli is found largely throughout your large intestine and small intestine, for that matter, but mainly large intestine. And it's not bad for you, but certain strands of E. coli are so bad for you that they can kill you. So obviously we need to treat that wastewater appropriately. Now, a simple way to treat it, if you have a lot of land and a relatively small amount of wastewater, is through septic systems. Some of you, I am sure, have a septic system at home. Okay, if you don't know if you have that or not, if you live in a rural area and you have usually some sort of like pipe coming out of the ground in your backyard or somewhere, you probably have a septic system. And what that is, it's usually one or two large receiving containers that are connected to this leach field, these pipes, and I've seen some that are 5 or 6 pipes, and then I've seen some as little as like 2 or 3 pipes, depending on how much water you're going to pump through it. These pipes that go out from the receiving container into a field, and everything is sort of buried over. Okay, those pipes are perforated so that water can seep through them, and what happens is your raw sewage, literally all of your wastewater, goes into this larger vessel, this septic tank, and it separates out, usually through bacterial processes. So you have bacteria that are inside of this tank, and they are eating away at the sewage that you just created. I know we're getting kind of gross at this point, but that's what happens. And they effectively take your sewage and they separate it out into 3 layers. The top layer that rises to the top, it floats to the top, this is called the scum. The middle layer, which comprises the majority of your wastewater, which is septage. Okay, that's what it's called. And then the bottom layer, all the stuff that falls down to the bottom, which is the sludge. Okay, again, I hope you're not eating right now, because I'm sure this is kind of a disgusting talk. But these 3 layers, the septage is the largest one, and it's also the cleanest, and it gets filtered out into the leaching system that's attached to your septic tank. It goes basically out into your lawn, and your own soil, your yard, absorbs all of this water. And little microbes in the soil basically filter out anything that's left in that water and make it clean. It's a beautiful process. It really is. It requires no electricity. All it works off of is gravity. And at the end of it, you get good, clean wastewater that can flow into a lake or a river or a stream or a creek that you have next to your house, whatever it might be. And it's fine. It's perfectly acceptable. Now, you do have this sludge layer that you have to attend with usually once every like 10 years. So it's got a pretty good shelf life. Somebody has to come out and pump that sludge out. If you have a really big house with lots of people, it might be once every 5 years, but still 5 to 10 years, you pump out this sludge, and maybe you get some of the scum out as well, and you're good. You're good. It just keeps going. And they take that sludge and they take it to a better processing plant. So this is sort of a small-scale water processing plant in your backyard. Now, what you do when you have a lot more room or a lot more people is you get to what's called a sewage treatment plant or a wastewater processing plant. Now, why do we have this? Why doesn't everybody just have a septic tank? I just told you that it's more environmentally friendly. It requires incredibly low maintenance. It's a great system. Well, not everybody has a couple acres of land that they can build their septic tank on. You need to have at least, I would say, I don't know. I don't own a septic tank. I live in town, so my water is hooked up directly to the water or the city sewage system. But you would have to have at least, I would think, a half acre in order to have a quality septic tank. And even then, you'd probably be butting up against another leaching field. It would just be bad. I don't think that'd be enough room either. But what we have instead, if you don't have that kind of land, which I don't, I live on, I think, like a quarter acre, something like that, which is actually pretty large in my neighborhood. Most people have just like a standard lot. So instead, we pump our sewage to a water treatment facility, which is sort of like a large-scale version of a septic tank. They use some other methods. Okay, they might use chemicals. Most of them don't, but they might use filtration to a certain degree, usually some sort of mechanical filtration. But for the most part, they let the water sort of sit in vats and do exactly what a septic tank does. They use microbes to eat away at the waste products, the organic material that's found within that wastewater. So there are some problems with them. The main thing is that plants have a limited capacity. And if they are an older plant that hasn't been updated, normally, like, they'll put a plant in when a city or town is so big, right? But then the city or town grows, so that means that the need for more water processing increases, and then we get to a point where we get like maybe a high rainfall, and all that sewage is being mixed in with rainwater, because most of the time our drainage, our storm drainage, is goes right along with our sewage drainage. So they are forced to process huge amounts of water that they don't have the capacity for. So they actually have to dump out a whole bunch of wastewater. Okay, and this is completely legal. Surprisingly, and this shocks me, we can do this. You can take a water treatment facility, if it reaches its capacity, and there is still water coming in, they can literally just dump it out into the creek or river that they are usually beside, and that will flow down into the Mississippi in this area and then down into the ocean. Why is that legal? Because they don't really have another way of processing that. The only thing that you can do is if you've reached capacity, is you can update your facility. You can build either a new plant or you can update your existing plant. And the problem with that is it costs lots of money. It costs a few $1 billion to create a modernized water treatment plant. So a lot of places just say, no, if we reach that capacity, which doesn't happen all the time, usually it only happens in heavy rainfall, so maybe once or twice a year for some cities, maybe even as much as 10 or 15 times a year, but still, that doesn't justify the cost of a brand new facility. So they just say, all right, we'll dump it off. No big deal. So, like I said, that's some of the downsides. They also don't process farm animal waste. That is usually the responsibility of the farmer to do that himself. And what they do is they make their own sort of open air septic tank, which we call manure lagoons. And that is exactly what you think it sounds like. When you are processing or growing rather huge livestock and you have thousands of heads of cattle or even just hundreds of heads, they are daily defecating and you need to do something with all their waste. So what they do is they shovel it, usually with like a backhoe, into these large lined pits that they call manure lagoons, and they let it sit there. Could you imagine this little lake of poop? They let it sit there, and over time bacteria work their way through it. It dries out, so all the moisture comes out of it, unless there's a heavy rain, but still. And then they use it as fertilizer for their fields, because most farmers that grow livestock also either grow crops or they use it to fertilize their fields for grazing of those livestock. So really weird way to kind of deal with that, but it's something that we have to do. I think, that was the last one for today anyway. I'm going to come back. Like I said, this was a little bit of a shorter video, still managed 18 minutes, but we're going to come back. Make sure, guys, you sign in today, okay? Tomorrow I'll have another video for you. I'll see you then. Bye.